This is our project. It is MusicGen, an innovative approach to automatic music generation. Essentially, the way that our project works is that it creates a tune for the user based off of an input that is an emotion that is inputted. So if you're feeling happy or sad, what our system will do is it'll randomly generate a tune that also sounds happy or sad using Markov chains. And Markov chains are a mathematical system where the next state depends only on the current state and not on any preceding sequence. So essentially, each tune will be that you hear will be random and will be different each time. And what we did was we actually generated the probabilities of the tunes using existing songs that sound happy or sad or whatever type of emotion. So we had two main files, matrix.ml and music.ml. The user will input in how they feel through the command line. They have 5 emotions: upbeat, relaxed, sad, frantic, and capricious. Capricious is where you don't know how you feel, and so you want to hear music that is based off of all different kinds of emotional sounding songs. So you'll get something interesting and not necessarily happy or sad or relaxed, etc., but a combination. So matrix.ml is our module that defines the matrix. So our matrices are float array. Music.m matrix actually will just initialize a new 13 by 13 matrix. Some row will return the sum of each row, some vector, the sum of the vectors. Get_alt will return an element in a specified row or column. Change values by divide will change each of the values within a row by dividing the existing value by a certain number that you input. Vector change is a helper function to vector mult, which multiplies a matrix by vector. Music.ml starts off with defining types, so note, pitch, event, object, and stream were defined in pset 6. A song is a type that we define that will have an emotion that we can match with, a pitch list, and a length list, so how long are the lengths, what are the notes itself. Then we also had fixed definitions for volume, standard octave, the emotions list, so the 5 that you saw before, and the song list, so the actual songs that we would be using to generate the probability. So the user input is defined given using the function prompt, and then we have conversion functions for the song, convert plist to intlist and lengthlist to intlist, which will match the notes and the lengths to certain numbers using a match statement and convert the pitch list and the length list to int lists. This comes in helpful in our next function, which is note counter. So note counter will take in these int lists and it will look at each pair within that list and see how many times it appears in the rest of the song or that list, and it will increment that pair within the matrix itself. So for notes, you'll have the notes on the top as the rows and the columns, so each time a particular note follows another, it will increment in that particular spot. Same with lengths, except that instead of notes and columns, you now have like quarter notes, half notes, etc. Then you have next note, and what next note does is it'll give the next note based on the probability matrix, which we define with note counter multiplied by the current probability vector and the sum of the vector's indices. So then what that helps you do is that then we build notes and build lengths, which essentially puts this whole process all together. So build notes will take in an int, and that will tell you how long you want the song to be. So if you want it to be like, 50 notes or 25 notes, etc. What it will do is it will call in, once it takes the user input, it will actually match and see which songs have that input. So which songs are labeled relaxed or upbeat, etc. It will convert those into int lists, run those int lists through note counter, and get a new probability matrix. And then using that probability matrix, it'll call next note on those two probability matrices recursively, so that you keep getting new notes. And those notes will be stored in a list, so that list will become larger and larger as you keep calling it. You'll basically call that however many times you specified when you called build notes. So that's the main function that will actually tie that all together. And then we have list to stream, which is the function that will convert that list to a stream. And then we have a function output. Sorry, I didn't actually include this in the slide. And output will be the code that actually generates the MIDI file, which then you can see right here. So there's our gensad.midi. So it's time to see MusicGen in action. So let's go on over to our terminal. We're going to open up MusicGen. We're going to go ahead and make that file. Go ahead and call .music.native. And so once you run that, you can see here, please pick an emotion from this list. So let's go ahead and pick upbeat. And now we can look over to our MusicGen file, and sure enough, we have gen upbeat. So let's go ahead and listen to that. Okay, cool. So now let's go ahead and make another one. So let's run it again. This time say I'm relaxed. Let's go to our file, and there's a gen relaxed.mid. So we can play that again. Now, say that we, instead of actually typing in an emotion that's not in this list, we accidentally type in something else, like happy. Oh, sorry. I have to, call music.native. Say I type in happy, you can see that it's not a valid emotion. So then the user has to type in a valid emotion. So that's our music gen. In terms of challenges, one of our main challenges was actually debugging. So when our code wouldn't compile, we had to write a lot of assert statements and print out a lot of our matrices in UTOP to make sure that like the probability matrix was becoming different each time, etc. And then also one of the challenges was writing the tests, and so we wanted to, and like initially debugging those tests itself. So before we actually implemented the functionality, we wanted to make sure that we would have proper tests in place. Another like serious problem for us or challenge for us was MIDI conversion. So initially, we wanted to create a function that would read in and transform a MIDI file into like a note list and a length list that we would then be able to pass into other functions. But there are no other existing libraries out there that would be helpful, and so we'd have to build it ourselves, which was just like massive scope. Other things were code efficiency, so probability matrix. Initially, we had created a matrix with fractional probabilities, like 4/9, 2/9 instead of instances, and that would be like this appeared like two times out of 50 instances, etc. And that just ended up being really hard to then like be able to pick a note accurately based off of fractions. The other like main challenge that we had was deciding whether we would use a tuple matrix versus like two matrices, because as you know, song is defined with obviously emotion and then also pitch and length. And so we tried to like create a tuple matrix, but then that would mean either trying to run through the matrix once and simultaneously gathering information about both the note and the length, or running through the tuple matrix twice, which was honestly just as inefficient as having two matrices, and at least with two matrices we would know what was really going on. So those were the main challenges. That's a very brief overview of our project. Please look at our report for more. Thank you so much.